Hello, and welcome to today's webinar, How to Diagnose and Manage Technical Debt, part of our in-depth Tech Talk series. Today, we'll be discussing how you can tackle the technical debt that may arise during your active project, in addition to how you can build a clear prioritization guideline for your team during development. To discuss these topics today, I'm delighted to be joined by Joao Melo, OutSystems MVP and Tech Lead at PhoenixDX. I'm Kristina LeBlanc, and I'll be chairing today's discussion. Before we go further, a quick word on housekeeping. On your screens, you'll see a Q&A panel. Please feel free to ask questions as we go along, and we'll save time at the end of the presentation to address them. Also on your screens is a resources section, in which you will find helpful assets that support today's presentation. Finally, on the center of your screen, you will see the slides for today's presentation. Please note that this session will be available on demand and sent to you via email after today's webinar. Now that we've covered housekeeping, I'd like to pass it over to Joao.
Hey, Kristina, thank you very much. Thanks for having me. All right, so let's jump into it. My name is Juan. I'm an OutSystems MVP and the principal tech lead at PhoenixDX here in Australia. I've been in the tech industry for over 18 years, working as tech lead for the past 10 years, and with OutSystems for more than 7 years. Now I'm looking after the Phoenix's tech leads chapter and mentoring other tech leads while contributing to practices around solution design and software architecture. I just thought of bringing this funny chart as a provocation, and I wanted to propose a reflection. The question is, how often do we take stock and look backward in our projects? Software delivery in a sustainable manner is what we'll be talking about today. Just a very brief agenda. These are the topics I'm going to cover. So what it is and also what it's not. The impacts of technical business of technical debt in businesses and the most common root causes. And I'm gonna bring a model to master technical debt, pretty much based on my own personal observations and experience. And then I'm gonna hand it back over to Kristina for a Q&A session. Just setting the scene on the audience, although some of the terms I'll use here are more towards technical leads, as that's the main audience of my articles and everything I talk about. Developers, architects, engagement managers, product managers, and project managers are all welcomed. And I think they might also benefit from this talk. So let's delve into the technical debt topic a little bit. And first thing I wanted to discuss is its main definition and how people define it. So simply put, technical debt is the coding you have to do now because of the shortcuts you took yesterday. That's a pretty funny and interesting definition. That was brought from, it was brought in the growing threat of technical debt report built and shared by OutSystems recently. I just would like to have us all considering a scenario. So imagine that, for example, you're a tech lead or developer and you're in the middle of a sprint. Story is yet to be peer reviewed. Testers are waiting for them to go ahead and close off the sprint. Life must go on, right? And you need to keep going for the sake of the continuity of the project. You don't want to hold the testers team up just because you didn't peer review stories. And then you decide to release a new build, accepting that the business agnostic widget was left behind in a core layer module. So I'm pretty sure that all the technical leads and all the developers in the audience are going to relate to that feeling. Um, and that's pretty much a very simple and low-level technical example, a scenario we quite often stumble upon in our software development projects. In this slide, I just brought some well-known definitions of technical debt by two of the most important players in the tech industry. First, the Carnegie Mellon University defined technical debt as the trade-off between the short-term benefit of rapid delivery and the long-term value. So it's really about the choices you made while you're building your solution. And Gartner says it's about the deviation of an application from any non-functional requirements. And something I would like to highlight here is this interesting aspect related to non-functional requirements. The thing is, you don't want to measure the functionalities that got simplified or even removed from the scope or the features you're going to deliver due to budgetary or time restrictions as a technical debt. They're just a functional reduction of all the application, and they shouldn't count as technical debt. That's what pretty much Gartner suggests. But then you might be wondering, but am I really dealing with the technical debt? So that's a good criteria that I normally have in mind in order to have a good understanding of whether I'm dealing with technical debt or not. So changes that follow the remediation of technical debts are not supposed to affect the behavior of the app from a functional perspective. So it's pretty much whatever you need to change in your code, in your application, in order to tackle a non-technical debt, should it affect its behavior? There's a lot of controversy in this discussion, but just to help exemplify and illustrate this challenge, consider that, for example, you're building a purchasing order management app, and you consider you definitely need to have a database of vendors, right, or suppliers. But consider that the system of records for vendor is an external application. It's a legacy ERP, for example. And if you want to build your purchasing app, you don't want to have duplicated features, and you might want to consider to keep the original system of records as the origin for vendors information. And what you need, as it doesn't have any API yet built to expose vendors data, what you need to consider in order for your team to get cracking is you want to bootstrap vendors data, right? So consider that as you made the design decision not to have a vendor's CRUD or vendor's management kind of UI feature because your ERP is already taking care of that requirement. The decision around the functional requirement of not having a vendor's management UI feature is not a technical debt. It's really a project decision. Now, considering that you decided to import vendors through a bootstrap can be considered a technical decision because you know that in the future you're going to need to you're going to need to replace that database bootstrap with a real proper integration. So that's pretty much what we refer to when we discuss about functional aspects around technical debt. And in order for you to effectively define what something is, you need to clearly state what it is not, right? So just would like to bring an interesting definition here, well said by Uncle Bob, a very important best-selling author in the software industry, normally around software design principles, and he's one of the co-authors of the Agile Manifesto. What technical debt is not is a mess. So that's a funny description. A mess is not a technical debt. It's just a mess. So what Uncle Bob usually says is a messy code produced by people with who are ignorant of good design process practices shouldn't be considered technical debt. Another interesting background information I'd like to bring up is the Lehman's laws of software evolution. For the ones that are not acquainted, are not aware of who Manny Lehman is, he's just the father of software evolution, and he's been writing the area for a while. And the most important information he's ever written is the set of laws around software evolution. And you can tell by the years I put here that he's been thinking about it for a while. Some of his laws, and I just brought 4 of them here. Some of his laws related to the continuing change aspect of any software solution. So a system needs to be continually adapting, or it becomes progressively less satisfactory. Another important law is around the increasing complexity. Systems naturally have their complexity increased unless work is done to maintain or reduce it. Another interesting law is the continuing growth. The functional content must continually increase to maintain user satisfaction. Especially in the times we live, where requirements and business processes and even challenges change so often. If a solution doesn't change functionally at the pace that the business needs, it really decreases user satisfaction. And another important law is about declining quality. Quality will always appear to be declining unless it is rigorously maintained and adapted. So it has to do with users' perception. So as you can see, most of his laws are based on user experience, user perception, user satisfaction. That's an important aspect I'm going to bring up over and over in this presentation. I just thought of building this funny illustration here and the constant challenge around keeping a high level of user satisfaction while dealing with divergent, contradictory forces. So at the same time as you have the challenge of continue changing solution and continue growing with your solution, you have pushing hard on the other direction, an increasing complexity and declining of quality. So how to cope with these contradictory forces in order to keep a high level of user satisfaction. I brought this interesting chart here. It comes from the OutSystems study as well. This is how much companies devote their IT budgets in 3 key operations. I'd like to highlight here how enterprises have been struggling to deal with addressing technical debt. So 41% pretty much of their IT budgets have been in the last years focused on addressing technical debt. That's to be honest, it's a really scary figure. That's a considerable amount of money to just tackle technical debt if compared to running their own core business operations, like in the status quo operations. This is very intriguing. Companies spend precious financial resources on maintaining and patching old technology. And at the same time, hard to find technical staff are frustrated with where they have to focus their time on. That's a really recurrent challenge. just discussing very briefly on some root causes. This is also a chart that was built by OutSystems in their study and made publicly available very recently. It's a study about the impact of technical debt in businesses around the world. And what's interesting to highlight here is most of the companies that were part of the research have stated that too many development languages and frameworks are part of their big problem to keep track of technical debt. So over 36% of the companies interviewed have referred to this as their main problem. The turnover in development team is also a significant problem. And the constant need to meet deadlines, which drives an increasing acceptance of non-issues to be addressed later, is another important factor. Another information that this study brought up is the turnover in development teams, which normally leaves new hires in charge of platforms that they didn't create and may not fully embrace or understand is a big challenge. So imagine yourself, new joiner in the company, needing to deal and manage and potentially extend or even inherit the technical debt from legacy applications. That's a big challenge, and as a technical guy that has been in the industry for over 20 years, it's really frustrating. It's coming from a personal experience. Now, just delving a little bit into this analysis and bringing another important study conducted by the Carnegie Mellon University. That's a field study of technical debt. That's a bit more focused on on people with technical background, and it's interesting to say how big the gap is between the item number one around bad architecture choices, if compared to the other common reasons here. So I'd really like to highlight here that architecture choices is the top one biggest reason in professionals with technical background when they assess technical debt. But then some of you might be thinking, well, let's just replace the architect making the wrong calls, and you're done with technical debt, right? It's easy like that. But here's an interesting aspect of it. And I'd like to refer to this guy here, Ward Cunningham. He's the one responsible for coining the term technical debt. It actually comes from a metaphor based on the financial era. So Ward Cunningham tried to coin a very easy to read and digestible term for non-technical people to understand what he was talking about. For the ones who don't know, what Cunningham is the creator of the first wiki and one of the co-authors of the Agile Manifesto. And he says that we accumulate the learnings about the application over time by modifying the program to look as if we had known what we were doing all along. That's a very interesting perspective. And he personally advises, I am never in favor of writing code poorly, but I am in favor of writing code to reflect your current understanding of a problem. So just quickly back to the main technical reason for technical debt and around the bad architecture choices being the top one reason. And just to make sure we're getting the point here, it's about choices you make as a team, as a tech lead, as an architect, as a developer, or as a BA, based on the knowledge you have at the moment. So that's what normally drives to technical debt and the feeling of frustration and the perception that the design you came up with is not leading the team towards the right direction. Just sort of bringing up another interesting quote here from Martin Fowler when he says a particular benefit of the debt metaphor is that it's very handy for communicating to non-technical people. So it holds some interesting topics here. I'd like you to keep it at the back of your minds because we're going to discuss about communication and non-technical people in a minute. And this is just to highlight that Ward Cunningham has this interesting video on YouTube where he explains where the technical debt comes from, the technical debt term comes from. Just a few words on the cost of avoidance, because it's natural to react to the term debt. No one wants to be in debt with anything, but the cost of avoiding the obvious assumption that technical debts are inevitable is just like in the monetary debt concept. Technical debt can also accumulate interest. So the longer technical debt is ignored or unaddressed, the more software entropy can occur and the more complex it becomes to tackle. Take the analogy of cleaning your own place, your own house. Technical debt is like cleaning by hiding everything under the couch. It is tidy for now, but nothing is in its correct spot. In its correct spot. You eventually have to spend time properly cleaning and organizing it down the road in order to find something that you're looking for. So that's an interesting and brilliant analogy I picked somewhere. I'm not quite sure where, or perhaps I just came up with it. And I would like to address a few points around what I've been calling a model to master or address technical debt. Just a quick disclaimer here. It's pretty much based on some research I've been doing over a few years, but also highly related to my own personal experience and observations. So please brace for a lot of assumptions and personal perspective. I've been trying for a while to coin some really easy and digestible rules when it comes to mastering or managing technical debt. And the rule number one I would like to bring up here is don't let them build up. Don't let technical debt build up. Tackle it at a regular and consistent basis. We're going to discuss a few techniques and aspects that can help with that in the next few slides. Rule number two is make informed decisions driven by the value to the business. If the refactoring you're planning, for example, doesn't bring any benefit to the business other than make your code look prettier, what's the point, right? So I've been seeing I've been consulting and helping a few development teams where developers feel that urgent, that frustrating, sometimes frustrating need to refactor the code just because they're not proud of it. But what's the point is the code is already live. It's fulfilling the business needs, and changing it is just going to bring some more regression testing and impact the business than just let it working consistently as it's been working for the last years or months or whatever. So I'm not saying don't address it in order to avoid headaches. I'm just saying be conscious. Deliver value first. That's a strong driver when it comes to prioritizing technical debt. And the rule number three here is bring the client or the owner to the party. it's all about sharing the load and responsibility with the owners of the app you're building. I'm gonna delve into these three rules in the next slides. First, I just would like to bring up this inspirational image. I definitely must have picked it from any image database on the web. But it's really just an inspirational message here. It's all about finding the balance. As pretty much everything in our lives, managing technical debt is about finding the correct balance. So the first big aspect I would like to discuss is about how to prevent technical debts. So let's delve into a few advices and recommendations I'd like to bring up when it comes to preventing them from happening in the first place. So leverage good practices. It's something, good practices is it's all over the web and the world we live in, especially in the software engineering industry. We keep talking about best practices and how to avoid the common pitfalls, and how to make sure I'm building a future-proof or future-ready solution. And what I can say is that the internet is full of goodies everywhere. Examples like this documentation I have on my screen right now. It's a masterpiece when it comes to technical documentation. It's a document that OutSystems has released a few years ago, and it's really helpful when it comes to drive the team's decision on what your integration strategy is gonna be. It's a really intuitive piece of document, and it's really detailed. There's also a lot of guidance around how you structure and how you break down your application into modules. Not to mention the well-known software engineering recommendations, but just to bring a very common way of structuring out systems applications. And I'm pretty sure that all the actors and tech leads in the audience are pretty used to the way of structuring and layering down OutSystems apps. But there's also a lot of interesting books out there I would like to recommend. And also on something I'm always big with my teams when it comes to knowledge in our area. Don't be too focused on OutSystems only knowledge. There's always good information out there in the software engineering area. And a few books I'd like to recommend here is the Refactoring from Marty Fowler, related to design, software design. A book that is, sometimes I feel like it's a little bit too verbose, because it's being written by software engineers with a lot of experience, but I really think it's worth it to look, because we're talking about Google here, so it's a really interesting and insightful book. Software development, design, and coding. It's another interesting example. There's also valuable content on the web, so a bunch of courses live in those training platforms like Udemy. Some very interesting and simple, lean ways of thinking about design patterns. That's an interesting read. YouTube is also an interesting way of learning new stuff. Of course, be conscious. People say whatever they have in mind, so always challenge, always seek information. But I personally find learning from videos and experiences and hands-on kind of demonstration quite interesting. And this is a really interesting book I stumbled upon quite recently. To be honest, I didn't read it yet. It's on my read list. But I could see Adam Thornhill's talk around technical debt and tools he's been using over the years, and he consolidated all his techniques in this book. So the talk is really interesting. It's on YouTube, and he consolidated his approaches and recommendations in this book. So it's definitely worthwhile reading. Another advice I would bring up, and it really can help any, irrespective of what role you're playing in your team, it's a really helpful attitude that benefits everyone involved in a development team. It's about challenging assumptions, but at the same time help find the balance. As a consultant, I know that I need to bring options to help my clients make informed decisions. And it's always about tackling their challenges. And at the same time, as a tech lead, I need to bring clear guidelines to my team. Sometimes it might make the team feel that I have everything sorted because, it's always that feeling of someone has already slept over it. So they must know it all, right? Which makes the team take things for granted. And not to say also the cultural aspects, right? Sometimes you're dealing with developers that are a bit scared of challenging or speaking up, especially when it comes to challenging someone in a leadership position. It's quite common, especially in our area with so many introverts. But to be really honest, and something I'd like to share about my personal experience is that most of the best results I've ever delivered when leading teams were result of a proactive team that challenged my assumptions, no matter where they came from. So this attitude helps bulletproof the applications that I'm building, I'm committed with, and make it less prone to technical debt. So if I can give especially developers, an advice is always challenge assumptions. Another good tip here, and that's pretty much for the whole team again, it's about avoiding over-engineered features. It's on the lines of the more code you build, the more technical debt you have. And I'm pretty sure everyone here relates to a very common statement. We should be building a future-proof solution or future-ready. We should try to um, cope for or prepare or get ready for future requirements or um, you know mindset. This mindset has driven a lot of projects into troubles, into problems. um, and again, I'm going to bring Ward Cunningham back to the conversation when he says bad decisions are made on top of the current knowledge, the current understanding of a solution. So if you don't have a clear strategy on how to test, on how to communicate your feature and your requirements to the business, to the end users, why build it, right? So always ask why, always understand the purpose and the benefit behind what you're building. Otherwise, you're gonna be committing to a fair amount of technical debt, and even worse, something that you cannot even properly or confidently test. Um, just moving forward, that's something I found really interesting, and here at PhoenixDX, we've been putting in place quite often in our tech leads chapter. We've been bulletproofing non-functional requirements pretty early in our projects. So it has to do with, I just brought this example of ever-changing integrations that tend to demand refactoring in several layers. So imagine that you start cracking, like you start building in your application, and in our world, in low-code development, that's all about the expectation of rapid delivery, right? We create that expectation, our clients and our partners, and we always want to start building as soon as possible, to start delivering value, to start raising the perception of value we deliver in our projects. But sometimes we just forget to validate some important restrictions, some important non-functional requirements. I brought the point around integrations because, it's in my experience it has proven to be the trickiest one, and the one that is most likely to generate technical debt. It is pretty much because it's dependent on external teams, external players, um, and especially when it's moving around. So imagine that you start building your UI application and you have an integration layer which becomes on an external application, and the server-side integrations, the server-side APIs are yet to be built. So they are going to be built as you move along in your project. That's a very common challenge. It happens all the time, to be really honest. And what we do is we tend to bulletproof our requirement specifications in the very beginning of the project. So as opposed to start building with what we know, let's think about it first. Let's iterate over our assumptions. Let's specify the contracts. Let's discuss what each of the attributes in my API post method means, what the purpose of each of those attributes and how they relate to the business requirements. Of course, I'm focusing on a very custom software development kind of scenario here, but it's just to illustrate the challenge around non-functional requirements. And the earlier you bulletproof them, the less likely you're going to face technical debit down the road. Now, another interesting aspect and a very important mechanism to be on top of technical debt is how you identify them. There's a bunch of techniques that are related to how you can identify and get on top of all the technical debts. First one I'd like to bring up is, needless to introduce this guy, Martin Fowler, one of the most important software engineers of all times, to be honest. As you can tell, I'm a big fan. He coined this term, code smell, and he defines it as the symptoms of poor design or implementation choices. It's about quickly and preferably visually identify patterns or standards that will potentially lead to technical debt. I brought here fair amount of examples, at least some of the most recurrent ones, and an example of how OutSystems handles it through architecture dashboard. So the first example here at the top left is hard-coded way of converting an object into a JSON string. Quick question here, just for everyone to be on the same page, is consider that you add a third field to the account object. You're gonna need to refactor it, and you're gonna have a bunch of dependencies down the road as well, a lot of regression tests and so on and so forth. This is an image, a screenshot I took from a presentation from Olga, another OutSystems MVP, who's been talking and written a very interesting article about code smells in OutSystems. So I really recommend everyone to have a look at it. I put the reference on one of the last slides, the link to her article. And the second image here down the slide is about a quite recent pattern that has been incorporated into architecture dashboard, which is related to duplicated code. I've been using it quite frequently in my projects, and to be honest, it has been proven really useful, and avoiding duplicated code, although I understand it's a really really tricky and sometimes hard to find. It's pretty useful when they're tackled early in the game, because they normally involve refactoring in established features, and the less regression tests you need to do, the happier the team you're gonna work with. Right? I just listed here some other easy to spot kind of code smells. Apart from hard coding, which I illustrated in one of these images, monolithic logic, duplicated code, cyclic references, incorrect dependencies amongst modules, client-server logic mixed up, or undocumented components. These are pretty easy to spot items, and especially with architecture dashboards, they're really easy to find. Now, on the other hand, there's a few other examples of code smells that I'm not gonna delve into these items as of now. I'm planning to write about them in the next upcoming months, but they really need a more in-depth kind of analysis in order to be identified. One example is violation of domain rules. So consider, for example, that client business rules validation action that was put on sales order core module. So why do you want client specific rules in a sales order in a module that's holding business rules around sales orders, right? So that's something that's not easily traceable, at least from through automatic tools as of now. But it's something that involves a human decision, pair of eyes, with some context about the project. So that's why it's an in-depth kind of finding. Other examples here, related to inconsistent data modeling. Data modeling, to be honest, is something I'm pretty passionate about. That's something I've been really keen and that's something I love to do since I started my career. And spotting inconsistent data modeling is always tricky because again it's always related to the understanding you have at the moment. But it's pretty interesting to understand, to realize, to see that by avoiding some normalization, well-known bad practices around data normalization and data modeling can help you avoid a fair amount of technical debt down the road. There's also an interesting aspect. It's an interesting metric that unfortunately we can't extract out of architecture dashboards as of now. But I'm pretty sure it's something that will be covered and supported quite soon. It's about the change frequency. The most changed modules or artifacts in your system, the most commonly changed actions or screens or blocks should be looked into as with special attention, because they're holding not only a significant opportunity to create and raise the importance and criticality of technical debt, but also because as they constantly change, it means that they are quite important from a business perspective. And there's also an interesting aspect around cyclomatic complexity, which is something I'm not gonna delve into right now. I'll definitely touch base on this subject in future articles. But it's an interesting metric to understand how complex your code is, not considering only lines of code or tacit measurements like this. So it's an interesting approach to understand the code and criticality, the complexity and criticality of your program or code components. I just brought this quick screenshot about OutSystems Discovery. Although it's been a really useful and important key feature for architects and tech leads to be on top of their landscapes. It's a tool that's deemed to be replaced by Architecture Dashboard. Most of its features have been incorporated into Architecture Dashboard already. I just thought of bringing this as a good memory from old times, but it was really helpful in managing dependencies amongst modules and finding where technical debt was, especially around architecture best practice rules violations. So whenever you have an upward reference or a lateral reference when it's not supposed to have, so that has been a pretty useful tool over the years. And it's pretty much all about if you look at two images I have on my screen now, like in what desk would you rather be working on, right? It's all about keeping your architecture and your desk and your artifacts clean and neat, and so that you have a long and prosper day at work and a productive day. So I would definitely prefer to be working on the second, on the right hand side one, as opposed to the left hand side one, although my desks sometimes look like the first one. um, Another interesting aspect I'd like to bring up, and again it's another screenshot out of Orla's article on code smells, but it has to do with coding styles. And to be honest, needless to say that just by looking at this code, it really rings a lot of bells and brings a lot of concerns. Not only, by the visual representation of it, but it's clear to see the amount of hard coding stuff and redundant logic. For sure, there's a better way to implement this function and to get the very same output, and while at the same time you reduce the likelihood of technical debt. Another good example, which I've extracted from my colleague's article, Leonardo Fernandez, another OutSystems MVP, who has just recently published a very interesting article around coding styles and how it can help tackling technical debt and in peer reviews processes. That's a very interesting way, example of how you can visually and quite easily spot something that is quite off. So if you look at the amount of redundant structures, signs, and actions being recurrently being invoked in this very same logic, it's apart from scary, it's really easy to spot and figure out that you quite soon will need to face some challenges and in order to avoid problems with this logic. So as just a quick example, imagine that you need to create a new input parameter and you need to pass it on through all these actions here. Just the regression tests needed out of this silly change just scares me out. Now, just touching an important item here around code reviews. Apart from the obvious advantages, that there are four big reasons why I challenge my teams to be strong at code reviews. First of all, it's all about bringing an outer vision, like that perspective from an outside eye, someone else with a different background, a different perspective, bringing insightful information and feedback around your code. It's also about an opportunity for mentoring. So consider that you're going to have more experienced people looking at your code and what you built, and bring their experience. It's also about reaching consensus. It's about having someone else thinking of what you need to build from a different lenses. So consider that, for example, you got the requirements stated in the user story wrong. And what you're doing is you're pretty much asking for someone to, hey, do you see it the same way I do? Did I get it right? And ultimately, code reviews is about shared ownership. It's about having that main feature in the application, not relying in one developer anymore. It's about empowering people and making them able to take on challenges as they go. So imagine someone needing to extend a feature that you built first time. Just the fact that it's not relying on myself anymore, it makes me really, really happy. Just as a matter of context, in the non-OutSystems world, I always bring this kind of insight. It's article written by Google engineers around their engineering practices, and they touch the code review in their developer guide, and it's really interesting to see how they aim at what do code reviewers look for. That's what typically a Google developers or engineer looks for whenever they're doing code review. There are interesting aspects related to design, to functionality, to complexity, interesting insights and tips on how to make the code simpler. That's a very interesting topic, which I'm pretty passionate about. I'm always looking at simpler ways of building things. As well as tests, naming conventions, comments. So it's a really interesting guide and something that helps a bunch of developers open up their minds. Now, that's another quick example of just an illustration of architecture dashboard and how it can be helpful on managing, identifying, prioritizing technical debt. I'm gonna get back to architecture dashboard very soon. Now, jumping over to another important aspect of technical debt, it's about how you manage technical debt. So first big advice I'd like to bring up, and it's a funny way of saying this, but that's what I've been advising, and I delve into this aspect a little bit in my article related to technical debt. It's about bringing the client to the party. And I normally use it on a funny way to draw attention to something that, quite often I see project teams, tech leads, architects, or even developers trying to hide the what they've been accumulating as of technical debts. And because it really happens when people try to take too much responsibility on their work, and they just forget something that's really important. What's been built has been built on top of the current understanding of the problem. And sometimes I see people tending to hide that from the client, and clients are not exposed to it. So it's quite hard to have them prioritize in accepting that we need to invest some time on technical debt as opposed to keep delivering new features or new stories. So my big advice here is help them visualize it. That's a key aspect around communication. It's about how we bring that perception of how important technical debts are to be tackled to the client. So just a few advices here. First one is about talking less techy. Most of the times clients are not ready to talk about technical stuff at the level we do. And they shouldn't, right? They're hiring us to do the technical stuff. So my big advice here is chunk up the conversation, bring it to business terms, make the client understand the importance of tackling technical debt from their lenses, from their perspective. Again, it's all about business impact. It's not about making your code look prettier. It's all about business impact. And I brought this chart here on the right-hand side with a very interesting, common, well-known and sometimes quite often referred to. It's a chart from the Project Management Institute website. But my purpose with bringing this chart up here is about a very interesting, lean, and simple visual user storytelling. So you can, just present a very easy to read and digestible chart like this to make them understand how important it is to tackle technical debt. And last but not least is about being consistent. Take every single opportunity you have to bring awareness around technical debt, about the priorities of what you're working with. Again, on architecture dashboard and on the hotspot view I mentioned before, this is just an interesting and intuitive an example of how architecture dashboard can help clarifying where your hotspots are. That's a heat map generated out of the amount of technical debt per module. So each box we see here is a module. The red colored ones are the ones where the most of the technical depths have been found in, whereas the green ones don't represent as much technical debt. Another important tip is about combining tools to spice up the outcomes. As I mentioned here, architecture dashboard is becoming a key and fundamental tool for architects and tech leads to be on top of their architectures. There's also Discovery, as I mentioned before, a bunch of other Forge components that can help get a good grasp of your architecture and solution design. But again, don't be restricted to OutSystems tools. There's a lot of other tools in the market around how you manage and prioritize technical debt. So I really encourage combining the tools available to get to better outcomes. Another important aspect is related to social and cultural aspects. I just wanted to bring up another question just to tease everyone in the audience and to think about it. So the question is, how hard is it to keep evolving your application when a developer leaves the team? That's a very teasing question. I'd like to invite everyone to think about. Social aspects is pretty much related to the dependence that you currently have on your team, on your app, on a single developer. I these aspects are pretty much related to how you coordinate the team, how you distribute your technical tasks, and how you make sure that you have a good distribution, a good diffusion of responsibility amongst your team members. So it's all about balancing, finding the balance again, about finding a balance on the most critical and important components in your application amongst your team members. Just a quick tip and an important one. You can find most of a very insightful information out of the versioning system when it comes to social aspects. So you can find, for example, whether a given module has been, how many developers have been touching a given module, how many modules a given developer has been working on, so that you have a good idea of the concentration of responsibilities. So it's really interesting to have a good grasp on social aspects when it comes to managing technical debt. This is a very quick slide I'd like to bring up. It's a study I stumbled upon a few months ago. The article has actually been written a few years ago, but it's about visualizing development effort. Jambros and Lanza, they used a CVS database to have a visual representation of how balanced the development effort is in a given project. And they provided some clear guidelines on, and the key message is the more balanced, the better. So as you can see in the chart D, the last one, it's representing the distribution between codes, and it was taken from the version control system history. So the more distributed the modules are amongst the development team, the better. That's what the image D is representing, as opposed to image A, where you have one developer managing the whole solution. Another interesting tip I'd like to bring up is check your temperature regularly. That's something to be considered, because technical debt is not something that you build a list on your very first sprints and then you leave it there and you don't touch it, or you don't you hope that it's going to be tackled eventually. It's something that is going to keep growing, it's going to keep evolving, and you need to constantly be revisiting and bring your team to the same page and bring the client to the same page. So it's all about keep consistently asking these questions. This is a magical quadrant that Martin Fowler come up with. It's a technical debt quadrant, and it helps you understand how much on top of your technical debt your team are. It pretty much slices the decisions around technical debt in 4 different quadrants. So whether you're reckless on your decisions or prudent or deliberate or inadvertent. Of course, this is a very subjective analysis. And again, it's heavily reliant on the knowledge and the understanding you have at the moment. But it's always interesting to have a temperature check with the team and understand where their understanding is around the decisions around technical debt. And last but not least, I just would like to discuss a little bit about how to prioritize them. Again, I just wanted to reinforce this message. It's all about finding a balance, aiming at value and business continuity. So it's all about the value you're delivering to the business. In the end of the day, it's all about our customers. Right? And I just brought some indicators, some insights that can be used in order to make your call around how you can prioritize technical debt. First one, which is an interesting one, and to be honest, there's no particular order here. These items can be applied depending on your team structure, your client culture, the complexity of your application, and all that. So one of the most interesting ones is around the interest rate. As I said in the very beginning, technical debt, just like monetary debt, they can accumulate interest over time. The more you keep technical debt dormant, the more problems you can have in the future. And again, it's a pretty subjective kind of assessment. You won't find any tool able to just bring the interest rate of your technical debt, although there's a few funny attempts out there in the market. Another interesting indicator is hotspot. As I explained earlier, Architecture Dashboard is an interesting tool that can help you come up with a good understanding of where your trending risks are, although it still doesn't cover change frequency. That's an important indicator, an important metric. I really recommend to have a good technically to have a good grasp on. It's about how important the modules and components in your application are. Another aspect, as I just touched, related to the social aspect, is the responsibility dispersion. It's about how balanced is your team or your modules amongst your teammates. And a recommendation I normally bring to my teams on how to tackle the architecture dashboard findings are really related to the phase you are at in the project. So during early phases, I normally recommend the team to prioritize items related to architecture, because again, these are high-level decisions, and the earlier you tackle them, the less problems you will face down the track. And also maintainability. Maintainability is all about deduplicating code and making the code legible, so that in the future you have new people changing features and they're gonna get a good understanding of the purpose of the feature, and it's gonna help a lot moving forward as you move along in the project. And when it gets closer to go live, that's the moment where I normally recommend to look at security and performance related kind of findings. I know, when it comes to performance, it's a bit some sort of controversy, because people, especially experienced architects, and I normally do that. I normally tend to do that. I normally ask the team to look after performance, well-known performance bottlenecks. early in the game. But the thing is, most of the performance issues are tightly related to the behavior of the data, right? So depending on how the data behaves, uh, you might or might not have performance bottlenecks. So what's the point of prematurely optimizing stuff as you don't know the data behavior yet? So early in the game, it might be a little bit of of an overkill to be too much concerned about a few, about some performance items. Of course, it is important to work on the well-known items, but I would focus more effort on tackling technical debt when it gets closer to go live. Um, Having constant checkpoints with the team is also really important. Again, it's about constantly reviewing and revisiting your assumptions and risks, and I normally use it as a learning opportunity. Us technical people, we normally tend to just spot our low-hanging fruit and something that is really easy to tackle, and you know what, let me just do it. I'll get it done myself and quickly it will be sorted. But then you lost a big opportunity to share the knowledge and have your team learning with that. So I normally take constant meetings, normally fortnightly or weekly. It really depends on the dynamics in the team, to review and digest what we have in technical depth and technical aspects. So I use it as a really interesting learning opportunity. Another topic is about being opportunistic. It's about, you have that screen widget that is sitting on the wrong layer. You know that technical data is there. You don't want to change it because you're going to need to ask testers to do regression tests, and you're going to need to trigger a lot of processes down the road. But what if you're working on a story and you need to change that block anyway? Why don't you just move it to the right place, right? So it really helps when you're in a heavy build mode, in a software development, in a software delivery chain. It's really helpful to be opportunistic and take any opportunity you might be presented with. Just to close it off, I'd like to ask everyone in the audience to participate in a quick survey I'm working on. I'd really like to get a good grasp of what OutSystems teams over the world think and what their perceptions are around technical debt. So please scan this QR barcode. You're going to be redirected to a Google form to fill in a few easy questions. And I personally commit to bring the results of the research along with more insights on my next articles and my next talks, including next step event, OSDC, and any other OutSystems user group or any other event in the area. Just a quick briefing on these are the links, the most important ones I would like to bring up, some links, some articles or videos or even some books on the area that discuss technical debt. So this presentation will become available, and I'd really like to recommend these links to be assessed. So now I'd like to hand it back over to Kristina to conduct a Q&A session.
That was perfect. Thank you so much. It looks like we do have quite a few questions that have been submitted, although we won't be able to get to all of them today. So please know if we don't get to your question, we'll do our best to follow up with you in the next few days. The first question we'll be able to answer today is, since I'm just one developer as part of a very large team, what impact can I have on technical debt?
Right, that's a very interesting point, and it denotes the proactivity and the attitude of this developer, and I totally support you. So my biggest advice in this is just call out, help bubble up clarity, bring that to the tech lead or the BA or the engagement manager's attention, and help them find the information they need to keep track of technical debt. Help them bring this up to the client's perception. I've had developers in teams I led as part of my tech lead journey that were always challenging my own assumptions. It's normally taken for granted that if someone is leading a team, they know it all, and they should have it all sorted. But this is really, really not true. Like being challenged by my teammates has always helped me grow, and it really got me where I am at now. And not only that, like it helped me bulletproof the solutions I helped design. So, technical debt can manifest through quite big and complex technical challenges. Um, but what we can say is that it's really inevitable. It's always going to happen. It's always going to be there. Um, a very very quick advice is I think if you consider some pretty typical scenarios like imagine that you're building a solution and you know that, for example, a given data concept is going to be fed by an external integration, but the integration is not there yet. Why don't you structure the code in order to reduce the complexity in the future when you need to flick it over to the integration, right? So you can, for example, build an abstraction layer that will hide the complexity and the risks of changing that in the future. You start with a temporary database, for example, and expose that data through your abstraction layer. And then the work of tackling that technical debt in the future will be way simplified, way easier. So it's just a very, very simple and low level example just to illustrate what I'm talking about.
Okay, perfect. The next question is, should you prioritize and manage tech debt differently depending on what kinds of applications you're building?
Right. Yeah, that's something I realized after a while researching about technical debt. And what I got to is that technical debt is not technical. It's of course you need coding down the road to react to them most times, of course. But managing them is more about communicating and having a good prioritization process. And it's also about handling expectations. So I would not say that the technical characteristics of an app, like for example whether it's on web or mobile application, I wouldn't say that it's key on this regard on managing technical debt. It's more about the value the app delivers to the business and about the risks it poses to the continuity of the business than anything else, to be really honest.
Okay, perfect. Thank you. And then the final question we'll be able to answer today is, how can my team find a balance between updating legacy apps and building new applications with tech debt best practices in mind?
Yeah, that's interesting because there's a direct perceived association between legacy apps and technical debt, right? And it's natural because it's where they normally come from. From a business perspective, the legacy application has been out there for a while. It had the chance to be experimented by end users. Therefore, there's a lot of feedback and also a lot of maintenance that happened all the time. So it's really natural that technical debt are identified and linked to quite often to legacy applications. Nevertheless, I strongly believe that managing and prioritizing them is all about business needs and the value perceived by the business. So I believe I was able to share a few of the practices I normally use and recommend teams to use when prioritizing technical debt. And again, it's all about finding a balance, about addressing business needs and business continuity. These are the three most important North Stars.
Thank you so much to Joao for taking the time to join us for today's Tech Talk, How to Diagnose and Manage Technical Debt. Please note that this will be available on demand and sent to you via email. Before we wrap up, I want to invite everyone in our audience to join us at the OutSystems Developer Conference on November 17th and 18th. OSDC is a conference by developers for developers and focuses exclusively on what you want to learn. Plus, this will be the biggest OutSystems developer conference yet, with speakers, trainers, and attendees joining virtually from all around the globe. Make sure you save your spot at this year's online event to get hands-on with new developer tech and attend actionable and technical sessions that focus on solving real-world problems. To save your spot, please use the link on the slide here, or you can also scan the QR code. Thank you so much for joining today's Tech Talk, and we hope you have a great rest of your day.